the exponential function. So we're done with quadratics. We're done with the squares. We're moving to exponential equations. Before we start exponential equations, we're going to explore exponent laws. So the laws of exponent. How can I simplify? How can I collect like terms when I have exponents? Okay? So the first thing we are going to examine is developing the multiplication law. Okay? So there's different first one that we're looking at is the multiplication law. So what happens if I have a to the power of 4 times a to the power of 5? What does a to the power of 4 mean? If I want to write it in expanded form.
A times A.
That's right. So a times a times a times a. Now I'm multiplying that by a to the power of 5. So that means I have a times a times a times a. So this is the represents the a to the power, right? Times a to the power of 5, right? Which is a times a times a times a 5 times, right? What does that give you? What's that when you do a times 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 a? How many a's do I have there? 9 a's. So that's a to the power of 9. Okay? So this is the expanded form, and this is the expanded expression as a single power. Okay? So let's write the next one. So I have a squared times a to the power of 4. So for a squared, I have a times a times a times a times a times a. Correct? So what does that give me? A to the power of 6. How about the next one? So I have a times a times a times a times a times a. So that gives me a to the power of 6. How about the next one? A to the power of 8. And how did you get that? Uh-huh. So I have 6 and then another a and another a. So altogether I have a to the power of 8. And yep. And how did you get that? So what do you see? Do you see any pattern happening here?
Yeah.
What is it? Add the exponent. So if you have the same base, right, and you're multiplying them, the easiest way to do this is you keep the base, you add the exponent. Okay? So for this one, I can keep my base, which is a, and then I add my exponent, which is 7.
Does that only work only if the bases?
Correct.
But if you don't make different?
If the bases are different, you can't add them. If I have, let's say, a squared times b4, right? That would be a times a times b times b times b times b. How can I say that this is... I can't add them. It's not the same number. It's not the same letter, right? So this stays as a squared times b4. There's nothing I can do, right? So you have to have the same base for this rule to work. Yes?
What if it's a different sign in between? Like if it's division?
We'll talk about that. We're talking right now about the multiplication law, and that's why it's multiplication. We'll talk about division and other different formats, okay? But for now, we're just talking about multiplication. Okay? I like how you guys think. All right. So the rule says if we have the multiplication, right? We're gonna keep the base, and then we're gonna add the exponent. Give me a base. Okay? So if I have 2 to the power of m times 2 to the power of n, right? I have the same base here.
Yes.
What's my base?
2.
So I keep my base as a 2,
M plus N.
and then I add m plus n, right? Whatever m and n are, doesn't matter, okay? I just keep my base as is, and I add my exponent. So if you look right here, product rule, I have it written right here, so you can always refer back to it.
You write 2m plus n or just 2mn?
2 to the power of m plus n. Right? So if I have, let's say, 2 to the power of 7 times 2 to the power of 3, that gives me 2 to the power of 10. Are we good with that? Look at my quotient or division law. So what happens if I have a to the power of 5 divided by a to the power of 4? So we're going to write them in expanded form. So a times a times a times a times a divided by a times a times a times a, right? So we know that when I'm dividing, if I have the same thing on the top and the bottom, I can simplify, right? So that crosses this crosses this, this crosses this crosses this. So what am I left with? Just a. Okay? Good. Let's write this in expanded format. So I have a times a times a times a divided by a times a. Cross an a out, cross another a out. I have no more things to cross out. So what do I have left? A squared. Right? Because a times a, which is a squared. How about the next one?
A to the power of 4.
Uh-huh. So cancel a, right? You see that I have no more things to cancel, so I have a to the power of 4. Have you caught the rule yet? What is it?
You subtract the exponent.
That's correct. So you leave your base, you subtract your exponent. Okay? So what do we expect the answer to be for the next one? A to the power of 4. So if I do, I leave my base, subtract my exponent, then it will be a to the power of 4. If you don't believe us, you can try it with the expanded form. What will be for the last one?
A.
So I would say that for my rule, for the division law, keep the base. Again, my base is not changing, guys. Keep the base. Subtract the exponent. Give me a base.
3.
3 to the power of 9. Or let me leave it as a letter for now. 3 to the power of m over 3 to the power of n. What would be my formula? Okay, let's look at an example. So if I have 3 to the power of 9 over 3 to the power of 2, 3 to the power of 7, because if I do 9 minus 2, keep the base. Remember when we were doing factoring and we had to factor a letter out? And then when we were dividing x cubed divided by x, we were left with x squared. Guess why? Because of this rule, right? So if I had before x cubed and I was dividing it by x, I told you you're going to reduce. So 3 minus 1, that's going to leave you with x squared. Do you guys remember that? Any questions about this? Then we have what? The power of a power. Okay? So now we're looking at the power of the power law. So I have a to the power of 4 to the power of 5. So that means I have a to the power of 4 5 times multiplied by itself, right? So a to the power of 4 times a to the power of 4 times a to the power of 4 times a to the power of 4. I don't know how many times I've said it so far. Okay, so 5 times. What did we say about when we are multiplying? What do we do with the exponent? We keep the base and then we add the exponent. So I have 4 plus 4 plus 4 plus 4 plus 4, which is 20. So keep my base, raise it to the exponent. That's gonna get a little too much, but let's try it. We'll try it once and then we'll see what do we think it is. So a to the power of 2 to the power of 3. So that's a to the power of 2 times a to the power of 2 times a to the power of 2. A to the power of 6. The next one is pretty simple. A to the power of 5 to the power of 2. So that's a to the power of 5 times a to the power of 5, which is?
A to the power of 10.
Okay, do we see any pattern?
Multiply the exponent.
Multiply the exponent. Okay? So if I multiply 4 by 5, I'm going to get 20. If I'm going to multiply 2 by 3, I'm going to get a 6. 5 by 2, I'm going to get a 10. Next one. 6 times 3, what does that give me?
18.
So that's a to the power of 18.
Yes.
And then for my next one,
A to what?
A to the power of 12.
a to the power of 2.
Yes, go show your work.
It's just on the side, but
Is this it?
so is it necessary to expand?
So you all,
Do you have to show that, or can you just?
No.
no. I'm just showing you why this is happening. Right? So on the test or on your homework, you don't need to because now you know the rule. I'm just showing you how the rule came into place.
Is
Okay?
this it?
What do you mean?
There must be a catch.
No.
Well,
this
when
is
you
it.
combine all of them together.
Yes. And you need to simplify that.
So the rule says, what does the rule say? Keep the base,
Multiply the exponents.
and that's when you have a power to the power. Give me a base. Any base, any number. 7 to the power of m to the power of n. Then it will be 7m times n. Okay? So if I have 7 to the power of 2 to the power of 6, that's the same thing as 7 to the power of 12. So what you're going to have to do, I want you to all these different examples, try them, okay? And then we'll take them out.